Hi guys, I'm just going to redo problem P8-5 because I made a mistake. Let me just get it here. It's this one here. Determine the maximum force P that can be applied, there it is, to this crate without causing movement of the 100 kilogram crate that has a center of gravity at G. The coefficient of static friction at the floor is μs equals to 0.4. Okay, so I made a mistake in the previous video, so I'm just going to try to quickly correct it. Remember that it says what is the largest force P that can be applied without causing movement. Okay, so when we say movement, we mean one of two things. The one is sliding or slipping, whatever that is. Okay, slipping or sliding. And the other one is tipping. Okay. So hopefully if you've gone through the previous videos, you'll see when we're considering sliding, we just consider the equilibrium equations that deal with the forces. And when we consider tipping, we look at the moments. Okay, so let's assume the way that we solve this problem is we assume sliding and not tipping. Okay, we assume sliding or slipping. Just a quick reminder that if we keep applying P, the frictional force keeps increasing. If we keep increasing P, the frictional force keeps increasing up until a point where at that maximum point we get Fs equals mu Sn. Remember, that is your limiting static. That is your limiting static friction, and you can only apply this equation at the point of slipping, the verge of slipping. I'm sure you've got the idea now. At the verge of slipping, or impending motion, that's the other word, impending motion. Okay, so when we say assume sliding, we say impending motion. That's our assumption. We're on the verge of sliding. We're about to start sliding. Okay, so what's next? Okay, so now that we've got that, we need to draw a free body diagram. There's our weight coming down there, our normal force. Notice our normal force moves a bit to the right, and we've got our frictional force. Okay, there's our free body diagram. Make sure you draw it in your test or exam. Make sure you draw that free body diagram. Okay, so the sum of the forces in the x equals 0. And we have P minus F equals 0. And remember, because we're at impending motion, this F we do know. This F is our friction force at impending motion. We know what that F is. Remember, if we're to this side of that point on the curve, then we do not know what F is. Rather, we have to just solve F like we would solve for any other unknown force. If we are at that point, then we immediately know that it's equal to mu Sn. Okay, I hope that's clear. Sum of the forces in the y equals 0. We have the normal minus the weight equals 0. Okay, so recall in the previous videos, I think on the video on equilibrium, essentially what I was saying is that when we apply this force, okay, to a structure like this that can tip over, one of two things happen. Okay, when we apply P, one of two things happens. Well, no, not one of two things. Both happen at the same time. Number one, the frictional force increases. Frictional force increases. Okay, and the other one, at the same time, the normal force, which was at the center of this crate, moves to that side. Remember that normal force is moving because it's as that P is increasing, as that P is increasing, it's increasing the moment, right? In order to want to tip this. So as that P is increasing, the normal force is moving to the right to counteract the moment caused by that P. Okay? So as we increase P, the frictional force increases, number one, and the second thing is the normal force shifts to counter the moment ph, where that is h, okay, that height. All right? I think that's pretty clear. So as we increase p, two things happen. The frictional force increases, and number two, the normal force shifts to counteract the moment. Now the question is, which one do we hit first? Right? So if we keep increasing p, does n move to the maximum point on the crate so that we're going to get tipping? Does that happen before the frictional force reaches the limiting static frictional force? Okay? So whichever one occurs first, if that occurs first, we're going to have slipping. If that occurs first, n moving to that side, then we're going to have tipping. Okay? So our assumption is that this has occurred first, and we solve, and n is equal to the weight is equal to 100 kilograms times 9,81. This was my mistake last time, which was 981 Newton. So that's n. So F is Fs, which is limiting static friction, which is mu Sn, which is 0,4 times 981. All right, which is 0.4 times 981, which is 392,4 Newton. And P is F is Fs is 392,4. So there is our, in order for us to have slipping, we need to, that's the maximum force that we can apply before it starts to slip. Okay? Then in order for us to have tipping, for tipping to occur, remember, P can cause either, as we increase P, friction force increases, and the maximum that the friction force can attain to is this value. The other thing that is happening simultaneously is N is shifting to the right to counteract the moment. Okay? And the maximum distance that N can go is up until that point. It can't move any further. When it hits that point, if we keep increasing P, it can't go any further, so it can't counteract that moment, so we're going to have tipping. So for tipping to occur, X must be maximum. Okay, what is X? X is that distance from the center to where the normal force is located. So the maximum that N can be would be 0,5, right? 0,5. So X is 0,5. So now, with regards to tipping, we need to check moment equilibrium. So that is sum of the moments about O equals 0. And let's make that point that we take moments about. Take moments about that point. So if we say counterclockwise is positive, we're going to say N times X. Okay, let's just have a look. That force times X, we're taking moments of that force about that point, so it's counterclockwise, is equal to P times H, P times 1.5. Okay, so minus P times 1.5 equals 0. All right, and we're trying to solve for that. So we have P 1.5 times P is equal to N times X, and we know that the normal force is 981 and X is 0,5. So P is then 98 times 0.5 divided by 1.5 is 327 Newton. Okay? So if we keep increasing P, one of two things, both things are happening. We're increasing the friction force and N is shifting to the right. And when P equals 327 Newton, this normal force has hit that maximum point there and it can't go any further. If we keep increasing P, we're gonna get a tipping effect. We need to get to P equals 392 comma 4 here, right, on this curve, for us to get impending motion. So we know that P equals 327 will happen before 392, comma 4. So this problem is going to tip first, and the maximum force we can apply is 327. Okay, so I hope that helped. Good luck. Cheers.